Consider the differential equation dy by dx minus 3y equals 3. Verify that y equals c e to the 3x minus 1 is a solution to the differential equation for any constant c. Part B, we need to sketch the solution curves for c equals plus or minus 1, plus or minus 2, and plus or minus 3, so 6 different curves. Part C, find the particular solution which passes through 0, 2. So once you know a point on the curve, you can find a particular solution as opposed to a general solution. Part D, find the equation of the tangent to the particular solution at 0, 2. So equations of a tangent, that shouldn't be too tough. So for part A, if we're verifying that a solution is correct, we can basically use it and go backwards. So just show that it works almost by substitution, really, just show that if y equals c e to the 3x minus 1, which is this, then we just need to show that dy by dx minus 3y does equal 3 when y equals that. So we'll start with the y. The y equals c e to the 3x minus 1. So now we can differentiate dy by dx. Simple enough, so the shortcut chain rule. You've got a function of a function, so differentiate the bit in the power. So the derivative of 3x is 3. So that's going to come to the front. So it would be 3c e to the 3x, and the minus 1 will disappear. It's just a constant. So dy by dx minus 3y, dy by dx minus 3y, well, that's going to equal, well, the bit we've just worked out, dy by dx, 3c e to the 3x, 3c e to the 3x, minus 3y, so it's minus 3 times what we've been told is y, which is this c e to the 3x minus 1. c e to the 3x minus 1. So if you look at that, you've got 3c e to the 3x minus another 3c e to the 3x. So these two cancel out. And then you just have a minus 3 times a minus 1, which is 3. So because the equation works, so dy by dx minus 3y does equal 3 when y equals c e to the 3x minus 1. That shows us that y equals c e to the 3x minus 1 is a solution. To the differential equation dy by dx minus 3y equals 3. Okay, so part A, simple enough. Part B, sketch these solution curves for c equals plus or minus 1, plus or minus 2, plus or minus 3. Okay, so basically we need to sketch 6 different curves. So we need to sketch y equals, I think if c was 1, it's going to be y equals 1 times e to the 3x minus 1. So that would be e to the 3x minus 1. We also need to sketch for c being minus 1. So y equals minus e to the 3x minus 1. And then we need to do plus or minus 2. So that's going to be y equals 2 e to the 3x minus 1 minus 2. So y equals minus 2 e to the 3x minus 1. And y equals 3 e to the 3x minus 1. And y equals minus 3 e to the 3x minus 1. So we've got to sketch 6 things. And if you look at them, they've all got this minus 1 in. So I think we could, if we just think about them in terms of e to the 3x or 2e to the 3x or minus e to the 3x, and then if we just shift everything down by 1 afterwards, it's probably going to be a lot quicker. So if I just draw a horizontal line here, so it's going to start off being the x-axis, and then it's going to turn into y equals -1. So at the moment, it's just a horizontal line. The y-axis won't move because if you think of e to the x as being a parent function, e to the 3x, you can think of that as a horizontal stretch or a y-axis invariant stretch, scale factor of a third, so just something horizontal going on. And then we just move everything down, so we don't have to worry too much about any y-axis issues. So that can be the y-axis, like that, and it will stay as the y-axis. Okay, so if we start with y equals e to the 3x, well, just think about it. If x was 0, so if x was 0, or y would be e to the 3 times 0. Remember, we're ignoring the -1s at the moment, so that would go through 0, 1, like this, and it would just sort of have its nice asymptote here as the x-axis, and it would come up like that. Okay, so then if it was -1, so if we had minus e to the 3x, we're ignoring the other -1 at the moment. Remember, if x was 0, that would pass through at 0, -1. Or really, it's just a reflection of the first one in the x-axis. Okay, so that one is going to come across like this. It's going to go through here. 0, -1's got the same asymptote. Starts to turn something like that, right? I'm going to change color for when c is 2 or -2. Okay, so if c was 2, just think if x was 0, y equals 2 times e to the 3 times 0. So 2 times e to the 0, 2 times 1 is 2. So this one's going to go through 0, 2. Remember, I'm totally ignoring all of these right now. I'm going to sort them out very easily. We're just going to shift everything down by 1 at the end. So the other one is going to go through 0, -2, like that. So 0, 2 is here. 0, -2 is here. They've got the same asymptote. It just turns a bit earlier and a bit steeper. So something like this starts to turn and goes up there. Okay, so the other way, something like this starts to turn up there. Now the 3's, remember, totally ignoring those -1s at the end. This is going to go through 0, 3 using the same reasoning, and this will go through 0, -3 using the same reasoning, because e to the 3 times 0 is 1, and 3 times 1 is 3. So that's going to go through here and here. Make sure you don't label any points yet. So again, same beginnings, turns earlier and goes up here. Same asymptote, turns earlier and goes up here, right? So this is our family of curves, and now we can actually apply this -1, so it's just going to be a translation. Doesn't go horizontally at all, but it goes 1 down. So if everything moves 1 down, the horizontal line that we've drawn, instead of being the x-axis, so for all of these sketches that we've drawn, that's been the x-axis, y equals 0, everything shifts down by 1, then the asymptote will shift down by 1, so this will become y equals -1. So now we can draw the x-axis in, which is 1 above. So this will now be the x-axis here. So we have the x-axis, we have the y-axis. Okay, so now we've done that, we can put some values in. So this is obviously the x-axis, so this would be a point 0, 1, 0, 2, and the other side 0, -1, -2, -3, and here is -4. Okay, so we've got the values in and we can label our graphs. So this black line is y equals e to the 3x -1. We have the other black line, which is y equals minus e to the 3x -1. For the red lines, we have y equals 2e to the 3x -1 and y equals -2e to the 3x -1. And for the two green curves, we have y equals 3 3e to the 3x minus 1, and y equals minus 3e to the 3x minus 1. So now we have a family of curves which represent particular solutions for c equals plus or minus 1, plus or minus 2, plus or minus 3. Part C, find the particular solution which passes through 0, 2. Now we have actually done enough work to just look at this and say the answer, but I will demonstrate the algebraic method as well. So we have a general solution of y equals c e to the 3x minus 1, and we're told a point on the line. That's when you use that information to find a particular solution, e.g. you find the value of c. So you actually can already see that only one of these curves passes through 0, 2, and it is y equals 3e to the 3x minus 1. So that should be our answer. If it isn't, then something's gone wrong, either with the graph or what I'm about to do. But I will show you algebraically as well. So the general solution, y equals c e to the 3x minus 1. So when you're given a point on the curve, so at the point 0, 2, at that point, so the y value is 2, so 2 equals c times e to the 3 times 0 minus 1. So e to the 3 times 0 is e to the 0, which is 1. So that would mean 2 equals c minus 1, which means that c equals 3. So particular solution is y equals 3e to the 3x minus 1. And we'll just look at our graph again. You can see this green curve here, y equals 3e to the 3x minus 1, does indeed pass through the point 0, 2. Part D, find the equation of the tangent to the particular solution at 0, 2. Okay, so this is a very friendly last part, I would say, probably possibly the easiest part. So, equation of a tangent is going to be, you can either use y equals mx plus c, or y minus y1 equals mx minus x1. The point being, tangents are straight lines, and they have exactly the same gradient as the curve at the point where they meet the curve, right? So we already know the point in common, which is 0, 2, so that is on both the tangent and the line. So basically, y equals 3e to the 3x minus 1. We did actually differentiate earlier, but it's quite a simple one to differentiate, so we'll just put it down anyway. So dy by dx equals, well, it's going to be 9e to the 3x, and the minus 1 disappears. So at x equals 0, dy by dx going to be 9 times e to the 3 times 0, which is 9. So y equals mx plus c, so that means that the points on the line, so at 0, 2, 2 equals 9 times 0 plus c, so that means that c must equal 2, and so the equation of tangent is y equals 9x plus 2. Okay, we could potentially have a look, and would that make sense? So basically you're going to have a straight line through there. Something like that, and that should have a gradient of 9. So obviously my curves are not exact, to put it mildly, but that would represent a tangent. It should have a gradient of 9.